Today we're going to solve trigonometric equations with multiple angles. Yesterday we did double angles, but we're going to take a look at things that we can't just as easily use identities for. So consider the equation 2 sine 3x minus 1 equals 0. Find all solutions. So writing an expression usually involving 2 pi times the integer n. And then part B says find the solutions on the interval 0 to 2 pi. So starting off, here's our equation. Sine of 3x does not mean sine cubed x. You can't divide by 3 because it's taking sine of 3 times x. Okay, so there's no way to get around it. Or is there? So we're going to replace, I'm going to say theta is equal to 3x because I am more comfortable with working with theta or something that's not 3x. This is not absolutely necessary to solve these problems. It's just helpful visually. 2 sine theta minus 1 equals 0. Okay, do I remember how to solve this? I add 1 on both sides. I divide by 2. And I get sine theta equals 1/2. Awesome. The first thing they've asked for us to do is to find all solutions of the equation. So first of all, which angles satisfy theta? And then we'll get to which angles satisfy x. First of all, sine theta equals 1/2. So, and we're writing these as expressions, right? So theta is equal to, that would be pi 6th plus 2 pi times the integer n, or 5 pi 6th plus any full circle. All right, here's an expression. Here are the two expressions that represent theta, but our original problem had x, so we need to replace or substitute back in. We originally decided that theta would represent 3x, so now replace theta with 3x. And there's only one more step to solve for x. That's divide by 3 on both sides. Instead of dividing by 3 or writing it as dividing by 3, I'm still dividing by 3, I am going to multiply by 1/3. Same thing. It's just that the answer key wrote all your answers factored, and I thought that was kind of nice and actually easier to work with. So we're going to leave it like that. You don't need to distribute the 1/3, at least not for this step. And then we do it on this side too. So we times this whole equation by 1/3, and we get our other value for x. We have successfully written two expressions that represent all possible solutions to this equation. Now let's do part B. Find the solutions on the interval 0 to 2 pi. Okay, you have literally written an expression for yourself to give you all possible solutions. So what we're going to do is use that expression. Starting off with n equals 0. We're starting off with 0 to 2 pi is the interval they're asking for, so I'm going to plug in 0 for the integer. Now we're getting actual answers. This is just an expression. Now we're getting answers. 1/3 times pi over 6 plus 2 pi times 0. And then plug in 0 for the other expression. For n, 1/3 is equal to 5 pi over 6 plus 2 pi times 0. This is 1/3 times pi over 6. And that is pi over 18. Yay, we found our first answer between 0 and 2 pi. X equals 1/3 times 5 pi 6th plus 0. And we get x equals 5 pi over 18. We still have a lot more angles that are solutions between 0 and 2 pi. So what's the next integer we're going to plug in? We started with 0, let's plug in 1. What is 2 pi with the denominator of 6? Well, that would be 2 pi is equal to times both by 6, so 12 pi over 6. So that's what we're going to be adding in each of these. Instead of 2 pi, we're going to call it 12 pi over 6. Combine what's inside of the parentheses, and we get 1/3 times 13 pi 6th. All right, that gives us 13 pi over 18 and 17 pi over 18. We're getting closer. How do you know if you're getting closer? Like, how do you know when to stop? Okay, so it appears as though all our answers are landing with an 18 as their denominator. So I'm going to go up to the interval and say 0 to, instead of 2 pi, I'm going to write that with the denominator of 18. So I'm going to times this by 18 over 18 to see what that is equivalent to. 36 pi over 18 is equal to 2 pi. So I cannot get 36 pi over 18 as an answer because it's not included. See, this parentheses means not included. Okay, so 36 pi over 18 or anything above it is not allowed. I have to keep going until I find angles that are not in the restrictions, and then we're done. So let's plug in n equals 2. 2 pi times 2 is 4 pi. I'll just show the steps. 4 pi with the denominator of 6 would be 24 pi over 6. 24 pi over 6. And you can always check. 24 divided by 6. Is that 4? Yes. Combine what's in the parentheses. We get 25 pi over 18 and 29 pi over 18. Now, are we there yet? Have we reached 36? Have we reached 2 pi? 36 pi over 18, 2 pi? Nope. Let's plug in 3. I can hear you groaning through the video. 1/3 times pi over 6 plus 2 pi times 3. Okay, 6 pi with the denominator of 6. That is 36 pi over 6. Now I notice that the numerator 36 is the same as the numerator up here, 36. So we may actually not need to do this, but I'm going to show you why it doesn't work. Pi over 6 plus 36 pi over 6. Oh, 37 pi over 6, and then when you multiply that by 1/3, you get 37 pi over 18. So 3 was too big for the restrictions. It gave us an angle that was bigger than 2 pi, and therefore we didn't need to include it. So how do you know when to stop? Well, you know once you have reached an angle that is outside of the interval, the restrictions they gave you. But also, what is factored out right here? 1/3. That's why 3 gave us an angle that was bigger than. Okay, when you distributed the 1/3, you were basically adding a full circle to an angle. And if you're adding a full circle to something other than 0, you're going to get outside of the interval 0 to 2 pi. All right, so the answers for part B were pi over 18, 5 pi over 18, 13 pi over 18, 17 pi over 18, 25 pi over 18, and 29 pi over 18. Wow. And let's do our second and final example. Consider the equation root 3 tangent x over 2 minus 1 equals 0. I'm going to replace x over 2 with theta, something just slightly more familiar, and solve from there. Add 1 on both sides, divide by root 3. Okay, and that's simply asking what angle gives us root 3 over 3 for tangent. Okay. Between 0 and 2 pi, there are 2 possible angles that satisfy this. But for part A, we're just writing an expression. We're writing an expression for all solutions. So we don't need to actually write those 2 angles, because if you remember, tangent, the 2 answers between 0 and 2 pi for tangent are always pi away from each other. They're always half a circle away from each other. So normally theta would give us pi over 6 and 7 pi over 6. And we would usually add 2 pi to each of these, but this is tangent. So we only need to take the smaller angle, pi over 6, and instead of adding 2 pi, we're just going to add pi. Now, students often get a little confused as to how this expression is enough when this 7 pi 6 is also here. But if you were to plug in 1 into this expression, what would you get? Pi over 6 plus pi. Pi over 6 plus 6 pi over 6. That's 7 pi over 6. So the answer 7 pi 6 is embedded in this expression. It's already there. This expression right here is full coverage. Okay, so that's the answer for part A. Now we need to know, find the solutions on the interval 0 to 4 pi. Now, that looks scary because the 4 pi is really big, and number 1 was just 2 pi, and we had to do a lot of work. But the nice thing about tangent is that there's only one expression, so we don't need to plug in into 2 expressions. We just plug into this one expression. Okay. Seven pi over 6 is embedded in this expression, okay? Full coverage right there. But this expression is an expression for theta, and we started off with an x, so we need to substitute in that x over 2 for theta. X over 2 is equal to pi over 6 plus pi. Now we will multiply both sides by 2 to get x equals 2 times pi over 6 plus pi. Again, let's write it factored. It will make our lives easier. They want all values between 0 and 4 pi, so we're going to start by plugging in 0 for n. Okay, so this expression covers all possible solutions, and now we're going to plug in individual values to find anything between 0 and 4 pi that is a solution. N equals 0. That would be 2 times pi over 6 plus pi times 0. That reduces to be pi thirds. Okay, we have our first answer on the interval. Let's plug in n equals 1. X equals, what is pi with the denominator of 6? Well, that would be 6 pi over 6. So we're multiplying 2 by 7 pi over 6, which gives you 7 pi over 3. All right, there's another angle. Okay, looking back at the restrictions, because I want to know when I can stop plugging in values for n. 4 pi, and all of our resulting answers are with a 3 on the bottom, so that's what I want to look for. How do I write 4 pi with the denominator of 3? That would be 12 pi over 3. Okay, so once I get to 12 pi over 3, I'm out of the interval. I have no more solutions. Or before that, right? Because 12 pi over 3 is not in the interval. Only up to that. N equals 2. Now, how do you write 2 pi with the denominator of 6? That would be 12 pi over 6. Two times 13 pi over 6 is 26 pi over 6, which reduces to be 13 pi over 3. Hey, 12 pi over 3 was the end of the restriction, so we did not need to plug in this one. Only 2 angles made it, okay? Only 2 angles were satisfied this equation as solutions, and we're on the interval 0 to 4 pi.